Hello guys, welcome to my new channel, Medicine Pharma Education. Actually, I have made already two videos previously, but the videos was lengthy, so that I'm converting this again. I'm making a new video for the same syllabus. I mean, today we are going to complete the UV spectroscopy. I'll break the videos so that you can easily get the topics which you wanted. Firstly, in today's video, we are going to study about the what are the topics we are going to cover in the UV spectroscopy and important questions, and we'll cover the introduction and theory. This is the today's topic. uh, welcome to my new YouTube channel, Medicine Pharmacy Education. Medicine is required for the patients, but for the students, information is required. Information as medicine I'm going to supply for the students. It's mainly for the M.Pharm pharmaceutics department, and other departments I will try to make the notes, or else we'll see in upcoming classes, in upcoming days. Okay, let's start with the UV spectroscopy, modern pharmaceutical analysis. UV spectroscopy. Mainly, the topics present in the UV visible spectroscopy are the introduction, theory, laws, Beard's law, Lambert's law, instrumentation about associated with the UV visible spectroscopy, choice of solvent used in the used in the instrument method, and the solvent effect. What are the solvent? How it affects the uh, result, and applications of the UV visible spectroscopy. Mainly, the important topics or the questions asked in the this topic are mainly the Beard's Lambert's law. You can see the Beard's Lambert's law. This is very important, and the deviations. Beard's Lambert's law and deviations. This is the main question which are asked several times. Beard's Lambert's law, and to find out the lambda max, we use Woodward's rule. This is also an important topic, and it's very easy topic to you should buy the values, standard values of the parental values. It's also a very easy topic and easy to understand. And the instrumentation of the UV spectroscopy. These three topics are very important: monochromators and two detectors in UV, so UV visible spectroscopy, and instrumentation. That's it. These three topics are very important, and other questions are asked like filters, barrier layer, grafting, and photomultiplier, etc. These questions are already repeated. The main topics you have to cover is the laws, Beard's law, Lambert's law, and instrumentation and Woodward's rule. That's it. These are the main three topics that you have to cover. That's it. And this UV spectroscopy, firstly, you have to be, before starting the UV spectroscopy, I want to tell you that if you learn the instrumentation of the UV spectroscopy, the instrumentation is covered in next upcoming IR, and spectrophotometry, flame, and atom. All the instruments are almost same. The detector used, whether it may be photomultiplier or phototube, etc., the same detectors are used, and the monochromators and the filters are almost same. There is no like difference in the instrumentation. So that if you study the UV visible spectroscopy, very you have to like spend the best uh, effort on this studying this topic. That's it, guys. This topic is very important, and based upon this topic, many topics are related. And in upcoming instrumentation, I'm not going to explain about the monochromators or the detectors, because I'll just mention uh, refer UV visible spectroscopy. So, guys, study uh, this concept very seriously. That's it. Next, we will just give an introduction that you have already known. Introduction of spectroscopy. What is meant by spectroscopy? Deals with the deals with the the study of interactions of electromagnetic radiation with matter. Spectroscopy is nothing but it's the study of the interactions of electromagnetic radiation with matter. The studies what are the effects of electromagnetic radiation on the matter is studied. That is called spectroscopy. Understood, guys? Spectroscopy involves the measurement and interpretation of electromagnetic radiation, whether observed or emitted, when the molecule, atom, or ion of the sample moves from one energy state to another energy state. This very simple definition. See what is meant by absorption. Absorption is nothing but when the amount of energy is absorbed by the molecule or ion, it moves from the ground state to the exit state. As the amount of energy is absorbed from the ground state, it moves the exit state. Here energy is absorbed. In emission, the light absorbed is emitted back, is emitted, emission. So it moves from excited state to ground state. That's the main difference. These topics already are covered in the B form. I mean, you have already studied. I'm giving just an introduction of these topics. Next, energy of the molecule. Energy of the molecule is a sum of rotational, vibration, and electric. These are to define the energy of the molecule. We have to add all this, so then we'll get the energy of the molecule. Again, next, what is electromagnetic radiation? What is electromagnetic radiation? It is a form of energy consisting of waves of electromagnetic field. See, it's nothing but the waves of magnetic field and electric field. It travels in the direction of propagation. Its x-axis or y-axis, it's it travels in any direction in the direction of propagation where electric field and magnetic field perpendicular to each other. That's it. This is the transferring of energy in the form of waves. That's the main electromagnetic radiation definition. Next, we will learn the fundamental units. What are the fundamental units? These are already very easy topics. I'll just recall you. Wavelength, the distance between two adjacent crust or thrust in a particular wave. You can see in a particular, it is distance between the crust or thrust in a particular wave, and it is expressed in nanometer, angstrom, and microns. And wave number is nothing but the number of waves per unit length per wave per centimeter, expressed in Kaiser or centimeter inverse. You can see the formula and the diagram. And frequency, a number of oscillations of a field per second, expressed in cycle per second, or hertz, or Fresnel. I don't know how to pronounce. Just prefer the Google. And C is the velocity of light, and L is and lambda is the wavelength. This is the diagram, guys. Next, we are going to start with the theory of UV visible spectroscopy. Mainly, by the name only, we can tell that ultraviolet and visible spectroscopy deals with the recording of absorption of radiation in UV and visible range of the electromagnetic spectrum. See, by the name of the instrument, the absorption of radiation in that range takes place. Here, the UV visible spectroscopy, and the absorption takes place in UV and visible regions of the electromagnetic spectrum. Understood, guys? It's very easy definition. Next, the UV region extends from 0 to 400 nanometer. It is subdivided into near UV region and far UV region. The visible region extends from 400 to 800 nanometer. Organic chemists use UV and visible spectroscopy for detection and for detecting the presence and elucidating the nature of conjugated multiple bonds and aromatic rings. Elucidating means explaining the structure, bonding, and their electronic configuration, etc. By this UV visual spectroscopy, organic chemists gather this data for analysis of the compound. Next, the theory. Theory of UV visible spectroscopy. The ultraviolet absorption spectrum rises from transition of electrons within the molecule or of ions from lower to the higher electronic energy levels. Here, absorption causes, then it moves from lower to the higher electronic energy levels. As I said already, if the energy is observed, it goes to the higher state. It is the ground state. It is the excited state. Next, the ultraviolet emission spectrum raises from reverse type of the transition. Here, what happens in emission? Emission, the energy is emitted out, then it comes back from the excited state to the ground state. That's the emission. When the molecule absorbs UV radiation of frequency, the electron in that molecule undergoes transition from a lower to a higher energy level. The energy difference is given by equals to hv. The okay, the actual amount of energy required depends upon the energy between ground state and excited state. This equation is given by E1 minus E0 equals to HV. It's simple. Very simple, guys. If you want to find the actual energy required for the emission or absorption of for traveling the ground from the ground state to the excited state, actual energy required, then we calculate uh, excited minus ground state, then we'll get the actual energy required. This is the actual energy required for the molecule or the sample to travel from the ground state and the excited state, to travel from the ground state to the lower state to the higher energy levels. That's the main formula for the traveling. Next, here you can see the energy absorbed in UV region produces change in the electronic energy. Did you understand? Change in the electronic energy. As the energy absorption occurs, then it causes change in the electronic energy of the molecule, resulting in transition of valence electrons in the molecule. As the molecule absorbs, here after absorption, it can the changes, what are the changes occurs to causes which causes the excitation of the molecule are studied. Mainly there are three type of electrons involved in organic molecule, right? It's better now. mainly mainly there are three type of electrons involved in organic chemistry. As all we know, there are pi electrons, sigma electrons and non-bonding electrons. These are called as lone pair of electrons. Mainly first we'll go with the favorite. My favorite is sigma bond electrons. They are involved in single bond between atoms. As you know, sigma bond is involved in single bonding between atoms. Excuse me. They have the highest energy. We all know they have the highest energy and require high energy of UV light for excitation. Sigma bonds have high energy and require high energy of UV light for excitation. Example, uh, paraffin. And the sigma bond occurs only in saturated compounds, because saturated compounds are single bonded compounds. Next, pi bond. They are involved in double bond or triple bonds. Pi bond between the atoms. They have the lowest energy than the sigma bonds and require lowest energy of UV light from transition of pi to pi star, sigma to sigma star. Next, N type. Pi type occurs in unsaturated compounds. Remember it. Add one point. Next, non-bonding non-bonding electrons. These electrons are involved, these electrons are also known as lone pair of electrons and are not involved in bonding. That's the main difference between the sigma and pi and the non-bonding electrons. They are not involved in the bonding. They have the lowest energy and require the lowest UV light for excitation, n to pi star. Next example, oxygen. If oxygen contains lone pairs, sulfur contains lone pairs, and potassium contains lone pairs, these are the lone pair of electrons which are not involved in the bonding. Next, this is uh, sorry, you have to write here n2 pi star, this one n2 pi star, non-bonding electrons. This one B, this one is A, not written. Okay, next this one is B, n2 sigma star, transition. It is occurs in the saturated compounds containing atoms with lone pair of electrons like oxygen, sulfur, nitrogen, and halogens. They require less energy than sigma to sigma star. I think so you have got the basic concept of what are the electrons involved in the transition, sigma, pi, and non-bonding electrons. We will know the what are the energy levels and the graph. Here the conversion occurs from the bonding to non-bonding. Sigma and pi are bonding and non-bonding are pi, sigma star and pi star. It is a graphical representation how the energy levels are distributed. First, bonding pi, bonding sigma, bonding pi, non-bonding n type, anti-bonding pi, and anti-bonding sigma. See, from the pi to pi star, it is the highest energy. It requires highest energy than any other molecule because it contains high energy, so it requires high energy for transition of electrons from the ground state to the excited state. Here next strong one is n2 sigma star. You can see here I have given n2 sigma star. The next one is pi to pi star, and the least energy required is n2 pi star. This is the basic theory, and the laws I will cover in the next video, the theory and the basic concepts of the UV spectroscopy. Guys, don't write the notes in between. I will show all the notes at once. You can just copy. uh, Guys, if you like this video, just like and comment, and if you want to give me any tips, you can give me, and you can pause the video and copy the notes, or else I will provide the notes through the link, but it will take time by creating the group, etc. For now, you just pause the video and write down the notes. That's it, guys. This is very new channel. I'm working very hard to write these notes, and so that, guys, please help me. Please, your subscribe means a lot. Just by one subscribe, you can really motivate me. I just get motivated just by increasing the views. But if you subscribe, it helps a lot for me, and I can provide a better notes. You can get better standard textbooks, and by referring these notes, you can write. It's the more than enough for your master's exams. And I have also referred these notes, and I'm also preparing for my sem exams, and my sem exams are completed. This point is extra. If you want, you can write, or else you can leave it until here. It's enough. This point also, you can start it from here. It's better understanding. If you read this, it's little bit confused. You can start from here. There are three types of electronic transition: sigma, pi, and non-bonding electrons. In next video, we'll cover the laws, Beard's law, Lambert's law. It's very easy. And this is the graphical representation. Sorry, where is my pen? Energy. You can just pause video and right. Next video will cover the principle and the laws. That's it, guys. Thank you for watching. If you are seeing this video till now, please subscribe and like and turn on the notification so that you may get the notification and prepare. And thank you, guys. Bye. See you in the next video.